Okay, students, so after varying theta and getting the corresponding value of h, now let us proceed by filling this row, this one, and this one, and this one, so that we can plot a graph of sine square theta on the vertical axis against 1 over h square on the horizontal axis. So here, I will show you exactly what you should do in the exam hall. Yes, so don't waste time. When you feel already these two, yeah, you have already your 8 marks. Be sure. Now, what you're supposed to do here, you have minimum 8 marks because 18 marks is going up to 16 marks. So you don't waste time, you fill here rapidly, you come up with a scale. And as for and as usually say, the advice that I'm giving to you students is that if the scale is like difficult for you to come up with it, leave it. Leave first of all the graph. You go and do the station that you know. You come back on it when you be like ready. Because doing a solving question of when you are done with some questions in an exam, it gives you what? It encourages you to do the most difficult part for you. Yeah. So when you do like 2-3 stations or even the 4 stations, when you come back to the graph, you have that energy back to do it, to come out with the scale and come out with your graph. So okay, without wasting time, we are supposed to calculate sine theta I and sine square theta. Now, you take your calculator. We are going very rapidly. You first of all use a rough paper here. So for the first value of theta, we are having sine 10. So I'll punch sine 10. Sine 10 is 0.174. Then I square it. When I square it now, I will have 0.030. I do same. Sine 20. I do same with sine 20. I will have 0.342. When I square it, I will have 0.117. I will do same. With the others. I will have so why doing same here? Now look up. You can see that what here 0.030, 0.117. Let us continue. When I will do same with sine 30. Sine 30 is how many? 0.5. When I will square it, I will have 0.25. There's it, 0.25. Now, you see that 0.030, 0.117, 0.25. You cannot really manage to do a graph with those 000. It's better for us to put it. It's better for us to put it what? To bring the decimal place here, so that we should use whole numbers. Like here, I can bring the decimal place here 1, 2 times. Here, like this. I will have 3.0 times 10 to the negative 2. It's okay. So here now I will have 11.7 times 10 to the negative 2, and here I will have 25.0 times 10 to the negative 2. So doing same with the others, you see that you come out with, you come out here directly with 3. You put here directly times 10 to the negative 2. So any value you are putting here, it should be times 10 to the negative 2. You have 3, you have 11. Than to plot those 0.030, 0. So that is it. And don't forget that any value you are taking here should be times 10 to the negative 2. Now let us do same with 1 over h. So when I will take 1 over 6, you see that 1 over 6 will give you, let us come back here, 1 over 6 will give you 1 divided by 6 will give you 0.1667. When I will square the 1 over 6, I will have 0.02778, and so on. When I will go down to our next lane here is how many? Is 6.1, pardon. So I will take 1 divided by 6.1. I will have this. I will have 0.1639. When I will square it, I'll have 0.0269 and so on. You see that here we cannot still manage and draw a graph with 0, it will be very difficult. So it's better for me to bring the decimal place 1, 2. Bring the decimal place to the right twice. Even twice will not be okay, because those values will be similar. Like there, if I bring 1, 2, I will have 0.0. I will have a 2.6, which is 69, which is the same as 2.7. So it's equal to 2.7 times 10 to the negative 2. Here will be the same. You see that I will have similar values. Better I go again like this, so that I should have 27.7 8, pardon, when I want up, 27.8 times 10 to the negative 3. So put your value in one decimal place, it will be easy for you to plot it. Then here I will have 20. I will simply have 26.9 times 10 to the power negative 3. So it means that here, please, I forgot here the unit is per centimeter. So here the unit will be, I will first of all put times 10 to the negative 3 per square centimeters, because we are squaring here. Okay, so students, so by replacing the value of 1/h squared that we are just calculating first, I will have 27.8 . Okay, students, so after filling our table, let us proceed by plotting the graph of sine square on the vertical axis against 1/h square on the horizontal axis. So now let's come and plot our graph. We are plotting on let me plot with a pen so that you should see very well. On the horizontal axis, we are plotting 1/h square, 1/h square slash per centimeter square times 10 to the negative 2. And on the vertical axis, we are plotting sine square theta slash times 10 to the negative 2. So that is it. So I will show you how to come up with the scale here very fast. I will start with the horizontal axis, that is the axis 1/h square. To come up with the slope, the scale, to come up with the scale here, you are supposed to consider your maximum and your minimum point. The maximum point here, or the greatest value here, is 27.8, and the smallest value is 11.8. And you should know how many divisions the horizontal axis is made up of. When you count here, you see that it's made up of 18 divisions. 18 divisions. It means that since I'm having 11.8 here, and my biggest value is 27.8, I can approximate here like this, and I start here at, let's say, 10. If I start here at 10, if I take now 10 plus 18, how many? 28 division. Let's say 28 division. So it means that my last value on my horizontal axis will be 28. And look at my biggest value here, or my last value will be 27.8. 27 is equal to 20. It means that my scale is okay. So I will go 10. I will use 1 square to represent 1 unit, starting with 10. So I will have 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, and 28. Okay, So that is it. Now let us now go for the horizontal axis. For our horizontal axis, on my vertical axis, and I know that for the vertical axis we are having 22 divisions. 22 divisions means that if I'm starting at 1 and I take 1 unit to represent 1 square, I will have from here, I start here at 0, I will have 22 division. I will end at 22. So that is it. So let us come here. Our biggest value here is 97 and the smallest one is 3. It means that if I start here maybe at let's say 5, if I start 0, 5, it means that if I take 1 square to represent 5 units, let us see, if I take 1 square to represent 5 units, it means that when I take 5 times how many division? 22, I'm having 110. So 110, you see that the 97 that we are having is slightly equals to 110. It means that that is a good scale. It means that my last point will end somewhere here, and my last point is somewhere here. It's taking almost 3/4 of my graph paper, so it's a good scale. So let us take it. Here is 5, here will be 10, here will be 15. Without wasting time, let us come and plot our points. Let us plot the points directly. Okay, the first point here is the point 3. We are starting with the x-axis padding. Is the point 27.8. Now when you are plotting the point, you don't waste time. 27.8, you should not come and exactly locate it at 27.8. No, 27.8 is near who? It's near 27. It's near 28. It is near 28, so I will consider this line. Then on our vertical axis we are having 3. 3 is in between 0 and 5 and near, because the middle here is 2.5, so it's between 0 and 5 but slightly greater than 2.5, so it should be somewhere here like this. You see that I'm putting a circle. It means that the point is located somewhere there. Don't waste time to go and calculate the exact position of the point. No, you don't have that time, so it's an approximation. Okay, you're estimating the location of the point. So that is my first point. I move to the next point. The next point is 26.9. 26.9 is slightly close to 27. So I'm here, 26.9 is slightly close to 27. And on the vertical axis, we are having 11.7. 11.7 is somewhere here. So I'm here. 11.7 is in between 10 and 15. But near, yeah, because the middle here is 12.5. The middle is 12.5, so it should be somewhere here. Should be somewhere here, like this. Okay. Now, next point. Our next point now will be okay, students. So after plotting all the points, you come out with this. Then, as I was saying, it's not obliged that your line should pass through all the points. No, all the points should not be on the line. What you're supposed to do is that your line should pass where the majority of the point are. It means it should pass in between. Yeah, if there's a region where there is like here 1, 2, 3 points, down there should be also 1, 2, 3 points, and then there should be some point that should be on the line. So making our best straight line to be something like this. So that is it. You see that 1, 2, 3 are on top, 1, 2, 3 are down, and then these 2 are on the line. So rapidly you choose 2 unknown points to come out with the slope. You don't waste time. You choose 2 unknown points to come out with the slope, and the slope should be large enough, not those small. You can come and do a small slope, I don't know, it will not be correct. So it's better for you to choose like this point. I can choose this point. It's better for me. And when you choose a point, you locate it directly, so that will be easier for you. Start by locating the x coordinate. So here will be 13, and remember, any point I'm taking here should be times 10 to the negative 2. So 13 times 10 to the negative 2, comma, then here in between 90 and 95, in between 90 and 95 is 92.5 times 10 to the how many? Times 10 to the negative 2. But in here Please correct here. Here is times 10 to the negative 3. I forgot. So any value I'm taking here should be times 10 to the negative 3. So that is it. Then you choose another point. You choose another point that will be easy for you to locate the values, the x and the y coordinates. Let me choose another point here. I can choose this one here. Yes, I can choose this one and start here. I'm seeing 22 times 10 to the negative 3, comma. Then my axis will be 35 times 10 to the negative 3. So you can call this your x1, y1, x2, y2. So that is it, students. So you don't waste time there. You have a x1, y1, x2, y2. So you go now. So this is your slope here like this. Let me represent it so that you should see. This is the slope. You see that the slope should be big. So this is it. Okay. Without wasting time, we go directly to the next question. Question 12. Determine the slope of your graph and the intercept y on the vertical axis. So I'll come here. I will know that the slope you're having the points already. Let me copy the points here. So the slope is equals to, we know that it is change in y all over change in x. So it will be y2 minus y1 all over x2 minus x1. You can know it already. So my y2, what's the value of my y2? Y2, this y2, 35, should be 35 minus y1, 92.5, or times 10 to the negative how many? Times 10 to the negative 2. So that is it. Times 10 to the negative 2. Then x2. What is the value of x2? This is it, 22. 22 minus x1, 13. All through times 10 to the how many? Times 10 to the negative 3 per centimeter square. Don't forget the unit. Okay. So when I will substitute, I will have negative 67.5 times 10 to the negative 2 divided by 22 minus 13. I'll have 9 times 10 to the negative 3. So negative 57.5 exponent negative 2 divided by 9 exponent negative 3. I will have negative 63.9. Now, here is per centimeter square, so the value will be centimeter square. So that is it. So I'll quickly come and replace it here. So it means that my slope is simply equals to 35 minus 0.5 times 10 to the negative 2 divided by 22 minus 13 times 10 to the negative 3 per centimeter square. So making the slope to be equal to negative 63.9 centimeter square. So that is the value of my slope. As easy as that, I have the value of my slope here. Now to find the y-intercept. The y-intercept is not difficult. I know that the equation of a straight line is equal to mx plus c. That is the equation of a straight line. So if I want to find c will be simply equal to y minus mx. And now I should choose any point for my graph. I will choose, let me choose any point here. Okay, let me choose this point. I think this point, if I choose point 22 times 10 to the negative 3 and point 35 times 10 to the negative 2. Okay, let me choose that point. I will come and replace here. I will have, so my c is simply equals to what? 35 times 10 to the negative 2 minus, in bracket, negative 63.9. X equals to what? X equals to 22 times 10 to the negative 3, making C to be equals to, I'll have 35 times 10 to the negative 2 plus 1.4048. So C will be simply equals to 1.76. So C, we can say that C is slightly equals to 1.8. So that is it. I will come now here, I will substitute it directly. So I'll come here, I will say my C is simply equals to y minus m x. Yeah, C equals to y minus mx. So from point 22 times 10 to the negative 3 and 35 times 10 to the negative 2 implies C is simply equals to, when I will substitute, you put there your answer is slightly equals to 1.8. Okay, so that is the value of C, and C here represent our intercept I. Intercept on the vertical axis, in fact, this is where we are supposed to put it. So intercept is simply equals to 1.8. And remember, it's not having an unit, because you cannot have a unit, because look at vertical axis, the intercept is there, is having the dimension of sine square theta, and the dimension of sine square theta is unitless, it's 1. So no unit, you leave it like that. Okay, so after finding the intercept on the vertical axis, we go faster. You proceed now with, given that I equals to alpha squared, determine alpha and state its physical significance. So we are saying that what I here is our intercept. We are saying that I equals to alpha squared. This implies alpha is simply equals to square root of I. So when I will take square root of I, square root of 1.8, I will have alpha equals to, so square root of 1.8, I will have alpha equals to 1.34. Our alpha equals to 1.34, and B, state the significance of alpha. So you all know that alpha should be what? Alpha should be the refractive index. So alpha equals to the refractive index, of the glass block. Yeah, we all know that alpha is equals to the refractive index of the glass block, because it has no unit. It has no unit, and since we are doing an experiment about refraction using a glass block, therefore that should be what? The refractive index of the glass block. Now, given also that S equals to this, find the value of beta. So it means that from there, beta will be simply equals to S divided by alpha square, yes, minus all this square root of that. So this implies I will have our slope negative 63.9 divided by alpha square. Alpha square was I, which is 1.8. With this minus, we cancel. Then I will do the square root of that, so that our answer here will be slightly equals to 6. So that is the value of beta. Now, don't forget, is beta having a unit? Yeah, I think beta should have a unit, because the slope is having a unit. The unit of the slope is centimeter square. Alpha is not having a unit, so it means that here the unit here should be in here up should be centimeters square. Therefore here should be simply centimeters. So that is it. Now state one precaution that you implemented in this experiment. Exactly. So for us to come out with the because this is the approximate value of the refractive index of a glass block. Normally it's supposed to be 1.5, but it's an experiment, so it's normal that we are not having exactly 1.5 or 1 point something, because it's sometimes 1.5, 1.7, but we are having 1.34. It means that there were some errors. Yeah, so to minimize those errors, the precaution that you people should do here is that you should avoid parallax avoid parallax errors. Avoid parallax error when reading. You should avoid parallax error when reading the protractor. When reading the protractor. When reading the protractor and measuring angle. When reading the protractor and measuring angles. So that is it. Even when when you are trying to align the third pins, you should close one eye also to avoid parallax error. So those are some precautions that you can put here to have your 1 mark. So that is it. So those are some precautions that you can put to have your 1 mark. Now the last question is draw the setup in this space below. Now the setup here is 2 marks. You should not waste time. So you are drawing the setup only for one, let's say for one incident ray and refracted ray. Don't draw the setup for all the incident ray and refracted ray. No, you waste time for nothing. So let us draw it fast. The setup, you draw your glass block. Yeah. You draw. Anytime you are drawing the setup, you should name it. You draw your glass block like this. Yes. Something like that. You draw a normal. Draw the normal. You draw the incident ray. You draw the incident ray like this. We all know that what incident ray will be bent toward the normal because the refractive index of air is smaller than that of the glass block. So the refractive ray will bend toward the normal like this. And when it will come out, to be bent away from the normal because it's leaving from what? It's leaving from a glass to air. And the refractive index of glass is greater than that of air because for that of air is 1. We are just for calculating that for glass is approximately 1.34. So we bend away again like this, exactly as we did during the experiment. So that is it. So here you name this is the glass block. Okay. Here you name this one as your incident ray. Yeah, refracted ray. You name this one as the incident ray. Please, here is incident angle, refracted angle. Here, refracted ray. So as easy as that, you have your 2 mark for the setup. So there is the setup. Here you name this one the normal. Okay, students, so you see that is all about the mainstream. So the worst mark of this year was not difficult. I think the exam also will not be difficult. So when you are in front of the paper, do what you are supposed to do. If you are ready, a student that is ready should not have difficulties. Yeah, a student that prepare well should not have difficulty with the mainstream. Okay, students, so if you want a detailed correction also under the stations, I will show you how to answer stations, how to approach it, how to attempt it, how to collect data and all those things. Don't miss the part 2 of the full correction of the Norwest Regional Mock Paper 3 2026. So thank you for watching the video and don't forget to like, subscribe and leave a comment. We are together.